Hello children, welcome back to CK classes. Myself Punis CK and subscribe to my channel for more learning videos. In my previous section, we have discussed about a number system in brief. So rational numbers and irrational numbers and together called as a real number system. Now let us extend our knowledge related to the lesson number system of ninth standard. Some numbers on a number line, they are not rationals. Then what they are? Suppose if you have a calculator app in your smartphone, if I ask you to find the values of root 2, just find the value of root 2, the answer could be something 1.414 etc. And the same thing, suppose if I ask you to find root 3, the answer will be 1.732 etc. So this expansion keep continuing, it will never stop. And also none of the what digits is going to repeat or recur. So these kind of numbers, so they are not rationals, but you can find a number line. Then what you call for these kind of numbers. So these kind of numbers we can call it as irrational numbers. Irrational numbers. So what these are irrational numbers? Who discovered them? In the beginning, around 400 BC, the Pythagoreans in Greece. The Pythagoreans were the followers of the famous mathematician and philosopher Pythagoras. So these followers recognized irrational numbers on the number line. So this tree were made by these Pythagoreans. So there are many people that give contribution to the irrational numbers. So now let us define formally what an irrational number is. Suppose if S is irrational, suppose you're calling S is an irrational, then it cannot be expressed in the form of P by Q, where P comma Q are integers and Q never equal to 0. So this was the formal definition of irrational number. So I'll repeat, if some numbers you can calling as irrational, those numbers cannot be written in the form of P by Q and PQ are integers and Q not equal 0. Hope you will define it. If number expressed in the form of P by Q, they are rationals, they are not irrationals. I'll take some examples of irrational numbers. So in general you can say root 2, root 3, root 15, root 27, even pi. So even pi is also irrational. We will study more about pi, why pi is irrational in future classes. So these all are irrationals. Among them, I'll write some of them. You just recognize the something difference between irrational numbers and rational numbers. Suppose if you write 0.10, 100, 100, 1, 4 zeros and continuing, and if you use 3.12, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So these all are examples of the rational numbers. The main thing you notice here, the decimal expansion of irrational numbers. So the decimal expansion of irrational numbers is neither terminates or not recurs, because the numbers keep continuing, but they never they will never terminate. Either they won't recur also or repeat also. So this is what the decimal expansion of irrational numbers. So I can conclude the decimal expansion of irrational numbers are either, so neither, sorry, neither terminating nor repeating or recurring. So keep this what 2 points in your mind. So what is the decimal expansion of irrational number? So they will neither terminating nor repeating or recur. They won't recur, even they won't terminate also. Suppose if they terminating, if they repeating, so you can call them as rational, not irrationals. The 2 points you just keep in your mind. The definition, the formal definition of what irrational number in irrational numbers and examples of irrational numbers and the decimal expansion of irrational numbers. Now let us fill this bag with some numbers what we have learnt already. So first I'll fill this bag with natural numbers like 1, 2, 3 and so on. So for this one I will have 0, then you might be knowing it, but it's going to become what? Whole number system. I'll have -1, -2 and -3, so it becomes an integers. For them, if I had 3 by 4, 2 by what? 5, some rational numbers, so I am adding them. So next for them, if you have some irrational numbers, so now finally this bag is filled with number system. You can call this number system as real numbers. So why I'm writing like this? So keep this point in your head. Don't forget it. All natural numbers are real numbers, all whole numbers are real numbers, all integers are real numbers, all rational numbers are real numbers, even all irrational numbers also are real numbers. So you can say the root 2 is real, yes, root 2 is real. Do you think pi is real? Yes, pi is a real number. Do you think 2 by 5 is real? Yes, you could tell that is. So all these numbers are considered as a real numbers. In general, I'll go for the keynote 1. Root m is irrational if m is either prime or non-perfect square. So this point is very important for the understanding about irrationals or creation of some irrational numbers. So in general, you can say square root of some numbers are always irrational except some cases. Suppose if you take square root of 2, it's irrational, and square root of 8 is irrational. So I could tell that is root 2 is irrational because 2 is a prime. Root 8 is irrational. 8, even though it's not a prime, but 8 is a non-perfect. The keynote 2. Here, root m is rational, and if m is a perfect square. I'll take some example of them. Suppose root 9 if you take. So we know that. So 9 is a perfect square. So you can say root 9, the value of root 9, so it would be equal to 3. Suppose if you take root 25, the value of root 25, it is 5. You could say that as generally square root of a perfect square numbers is always rational in nature. Keynote 3. So this very important keynote about number line. Every real number is represented by a unique point in the number line. So every real number has its own position on the number line. Also, every point on the number line represents some unique real number. So you just record this point. It's very interesting. So keep in mind. Every real number has a position on the number line, and every position on the number line there is a real number. So I'll just analyze it by drawing a number line. Suppose if you draw this is a number line, as you know 0, it could be taken as 1, this could be taken as 2, this could be taken as negative 1, and this could be taken as negative 2. So here, suppose if you say one number, just like this I'll take 1 by 2. So 1 by 2 is a real number, it's rational in nature, but it's a real in nature. So this 1 by 2 has a position. This 1 by 2 has a unique place here. The same thing, if I ask you what this position actually stands, what the number may come in this position, which could be a minus 1 by 2. So this I say it has 1 by 2 as a position. So every number has a position on number line, and every position as some number, what as real number, that's what this keynote. So watch this video 2 to 3 times, and you people have to solve the second exercise, first 3 questions without fail. You try them. Suppose if you are not getting answers, if you are confused about the questions what they asked, you can ask me in the comment section. So don't forget. So you just put a comment section, or you can send me via WhatsApp. Most people know the WhatsApp number of mine. So I will guide you how to tackle those problems. Thank you.